Debugging is the process of finding and fixing mistakes in your code. Sometimes the mistakes are easy to find because the program will give an error and it won't finish the rest of the code. And other times mistakes are harder to find because they might not produce any explicit coding errors that make your program crash, but those bugs can still give incorrect results. Those are the most dangerous kinds of bugs, and the only way that you can find and fix them is by careful and critical thinking. Throughout this course, I'm going to stress different methods of debugging, different strategies for debugging your code and identifying errors. And there's a whole section of this course at the end, the last section, that's just about debugging and nothing else. Now, one way to facilitate debugging, to make your code have fewer errors and less likely to have bugs, is to have good, what I call coding style. So I'm also going to talk in this video about what I mean by this term coding style, and I'll show you a concrete example of good style versus bad style. Where does this term debugging even come from? So it actually goes back to this woman, Grace Hopper, who is the original coder. I call her the OC. She was one of the first human beings ever to write computer code, which is pretty cool. So in some sense, she is like the grandmother of computer programming. And, well, the exact origin of the term computer bug is a little bit mysterious. That's a little bit debated. But it is known that she was programming on a computer. Now, computers were quite different back then. This was the early 20th century, so like 100 years ago approximately. Back then, computers ran on tubes, vacuum tubes, and all sorts of things, so very different from the digital computers that we have now. She got an error in her code. I think she was trying to solve a trigonometry equation, and she discovered that there was actually a moth, like a literal moth, the insect, that little annoying flying thing that's going to eat all of your clothes. So she discovered a moth had gotten stuck inside one of the vacuum tubes, and that's where the error was coming from. So that's where the term bug is attributed to this woman, Grace Hopper, and her original computer code. Pretty interesting. If you're curious to learn more about this, you can look this up online. There's lots of information on Wikipedia and other pages about Grace Hopper and the origin of the bug, including pictures of the actual bug and her code that she was running. Okay, so here's the thing about debugging. Debugging is an important part of your code. It's a necessary part of everyone's coding experience because everyone makes mistakes. Now, I know you're probably thinking that your great instructor, Mike X. Cohen, never ever makes mistakes. But unfortunately, it's totally wrong. I make tons of mistakes. Everyone makes mistakes in life, in work, in relationships, and definitely in coding. The thing you have to work on is not so much, thinking that you can never make mistakes. You have to work on your skills for debugging your own code so that you are efficient at identifying and correcting your mistakes. It's also important to realize that there are several different kinds of mistakes that you make when coding. Some mistakes lead to full-on crashes, and others are what I call silent but deadly, meaning that they don't produce any explicit error messages, but are still the wrong thing to do. And I've already mentioned these in the first moment of this video. And there's other kinds of mistakes that are fairly innocuous. These are technically errors, but they have only a very, very small and sometimes unnoticeable effect on the outcome. Now, debugging is not necessarily the most pleasant part of programming. It's not necessarily the most fun thing to do, but it is important, and there is good news. The good news is that critical thinking, planning, and checking, sanity checking, can help you prevent making bugs in your code. And even, if you do a lot of careful thinking and planning and organizing your code before you actually sit down to write it, when you do have bugs, then that can help you identify them faster and fix them faster. The other piece of good news for you is that I have tried to incorporate debugging and debugging strategies as a major component of this course. So I try to stress the ideas, the strategies of finding and fixing bugs as often as reasonable throughout the entirety of this course, including a whole section at the end that's just about debugging. So now I want to talk a little bit about coding style. Your programming style is basically the way you program. It's how your code looks, how it flows, and how it is organized overall. I think of it this way. There's a part of programming that the computer needs. The computer needs an organized string of characters that provides a set of instructions. But then there's a part of programming that humans need. That's the part of programming that helps you read, interpret, and understand the code. It helps other people figure out how to read and develop and extend your code. And good programming style helps you prevent mistakes and find them and fix them faster when you do make them. Now, everyone has their own programming style, just like everyone has their own speaking and writing style. So I can't tell you exactly what your coding style should be, but I can tell you how to think about it and what to focus on so you can develop your own personal, effective, and beautiful programming style. Let me show you a concrete example. Consider these two sets of Matlab code. Don't worry about what the code means or what it does. That's not important. What's important is to notice just how the overall look of the code appears. Now, it turns out that these are exactly the same pieces of code. They do exactly the same thing, and Matlab will interpret them in exactly the same way. Now, I will let you guess which one is easier for a human to understand. Which code would you rather work with? Which code would you rather have to debug and extend? Furthermore, imagine you are applying for a position for a data scientist or in a PhD program or a master's program, and your potential future employer asks you to provide a code example so they can see what your code looks like. Now imagine from their perspective, imagine you are hiring a data scientist or a computer engineer or a PhD student or postdoc, and you have two roughly equally good candidates on paper. One of them submits code that looks like this, and one of them submits code that looks like this. I will let you guess which person you would rather have working for you and analyzing data for you.